Hello, my name is Henry Bright, and I'm completing this XFLR5 project with my lab group, including Manuel Hernandez, Zachary Moore, and William Romito. So I'm going to do the first part of this video basically to explain how to use XFLR5 for the two different airfoils that we're looking at. And then one of my lab mates will be doing the same thing for the three-dimensional wing. So as you can see with this project, we're just working with these two NACA airfoils, 0012 and 4412, and getting the CL versus alpha and CD versus alpha graphs. So let's go ahead and get into it. So if I pull up XFLR5, it's just a blank screen when you open it up first. So we're going to go ahead and hit File, and then come down to Direct Foil Design. And then there's two different ways to do this. Not 100% sure if it makes a difference, but the easiest way is just going into foil and then clicking on NACA foil. So they have them all kind of already in their database, and you just literally have to type in the correct 4 digits for what you're wanting. So in this case, 0012 is the one that we want. So we're going to get that one in there, and then the other one that we want, other one that we want is our 4412. There is an alternative way of doing this, and again, I don't know if it actually affects results, but there is some convergence issues, so potentially this could be a slight solution, although it didn't seem to solve the issue for me. But if you go on to either airfoiltools.com or the UIUC airfoil database website, you can get these NACA airfoils. So for example, you've got the NACA 0012 here, and if you download the CLIG format DAT file, that's the one that you want because it'll be arranged with the coordinates correctly. Again, that's starting from the trailing edge. You want it to go up over the top surface of the airfoil and then come back around via the bottom surface back to the trailing edge. So that would be the correct coordinate file. If you look at UIUC, you can either download, they have a, where is it, right here, they have a zip archive with all of these in the CLIG format. For some reason, it didn't have the 0012. I don't know why, but it did have the 4412, so that was how I did it. And using those DAT files, if you go into XFLR5 and you want to import it, you would just hit File and then Open, and then hit the correct file, and it should move it with no issue. But anyway, we'll just go with this method. So now we'll go to File and then Xfoil Direct Analysis to do our two-dimensional airfoil. So we're starting off with the 0012 up here. You can see you can change to whichever one you need. And the first thing we need to do is define our analysis. So we go to Analysis, Define an Analysis. And it pulls this up. Type 1 is fine. And what we want is a Reynolds number of 100,000. That's what's specified in the project, so we go with that. Don't worry about changing the rest of this data, the Mach number, all that sort of thing. Should be fine. So we'll hit OK. And then you can see this box on the right is now not grayed out. So now we can actually use it to do our analysis. So we're going to go from a range of -5 to 25 degree angle of attack, and we'll just go in increments of 1 degree. So this all should be good. So let's hit Analyze. And boom, looks like we had no issues with convergence. Everything pops up. So you'll see this graph here. Let's see if I can pull it up. Yep. So there's our CL versus alpha graph. For those of you that don't know, if you hit your keyboard numbers 1 through 5, it'll give you like the graphs 1 through 5. So there's 1, 2, 3, 4, 5. But anyway, so this one is our CL versus alpha graph. So looks pretty good. 0 lift, angle of attack is 0. Makes sense for symmetric airfoil. And we steadily climb up until we probably hit that stall angle around 11 or 12. And then we kind of go back down, and then we have some weirder things going on. But yeah, so we've got that one. And then let me go back to all of them, and I'm going to change this one. There is our CD versus alpha. I can remember if I had changed the settings on that one. So that's what, 4? Yeah. So there's our CD versus alpha. So those are the two graphs we're worried about. And everything looks pretty solid. So we've got that data. Once you have this data, what we want to do, obviously you could take screenshots, but to be able to manipulate the data better and also to get our lift curve slope, we want to export this data. So what you would do is, like, if you're hovering over the CL versus alpha graph, for example, you right click on it. And if you go to current graph and then export graph, it'll pull up your file window so that you can export it, and you can change the name to whatever you want to, put it wherever you want it. And it's a CSV file, but it will import into Excel just fine. If you like go into Excel and like open the file from there, it'll work just fine. And you'll have all the data that you want. So yeah, that kind of covers that. I can show you what it looks like for the 4412 file as well. So we'll do the same sort of thing, find an analysis. That's exactly what we want. And then we'll do our sequenced analysis here. Everything looks like it converges again, and now we've actually got it on the same plot, which is kind of fun. You could always reset this. You don't have to do it this way, but this is actually great for comparison's sake. So yeah, you can see it's going to be the graph, like on the CL versus alpha graph, it's this upper one, so it's basically shifted up where, you know, the zero lift angle of attack is now moved back to a negative alpha. And now we do have lift at zero angle of attack. So that all makes sense. Everything looks pretty good there. And you've got it on the CD versus alpha graph too. It's going to be pretty similar. You know, you might have a little bit, yeah, I mean, it should be very similar because they're both streamlined bodies. So yeah, I think that pretty much covers it. The only other thing is, if you needed more precision on your analysis, another thing you can do is a batch analysis. So this kind of like lets you surround the Reynolds number and kind of iterate for data like all around your target. Especially if you're having issues with convergence, this can be very useful. We didn't really have issues with that here, but it can be helpful. So you could surround it, like, for example, we're doing 100,000 Reynolds number. So if you do like from 90,000 to 110,000 and you increment by 1,000, I'll go ahead and show you what that looks like. And it'll basically start popping up. You can see, like, in this upper left corner here, where it's starting to pop up more and more graphs that are like kind of surrounding that value we had for our NACA 4412. There might be a little, you can see there's going to be some issues. You can see we're getting some skewed points where maybe there's not some convergence, or there's just some like weird outliers that are happening. So that looks a little strange, but the gist of it is, like I said, it just helps to get you a little bit more of a refined solution around the Reynolds number that you're looking at. So there we go, that finished. And you can see, like I said, it did a few funky things on some of these graphs, but just can help a little bit. We didn't really need to do it here, but it can help with that. So I will stop this video here, and I will let, like I said, one of my group members take over to show you how to do it on the wing.